Welcome to the Pac-Clone series of videos. This video is of a technical nature and is intended for technically minded individuals who are interested in programming on the Commodore 64. Today's topic is covering redefining the character set, which we'll get into shortly, and in the end I have sort of a mathematical bonus segment and a quick update to one of my previous videos. Normally, redefining the character set is not that much of a problem. What can make it a problem is if you're tight on memory space. Unfortunately, in Pac-Clone, it is tight. There are a few things I can do to tighten up the code, such as reducing the number of sprites or changing the way I'm doing the animations, for example. Right now I have 37 sprites defined. There are savings to be had there. The other thing I could do is sort of a last resort is to load my plan maps from disk. I'm not quite there yet. Once my program fails to compile, I'll consider the alternatives. Since I'm tight on space, I had to rearrange the way the program places things in memory. My idea was to put all the data elements in the program first and then place the program data immediately following it. Unfortunately, the design of the Commodore 64 has something to say about that. I wanted to place the character set and sprite data in the 1000 area. This is not possible for either. That was 2 hours down the drain. So I proceeded to load the character set data at hex 2000, which is quite common. Then I loaded the sprite data at hex 3000, followed by the screen data, for example. Keeping in mind I can still place some program code in the hex 1000 segment. So far this is working out quite nicely. In moving the sprite data around, I found that I had quite a bit of hard-coded references to the location of the sprite memory. For example, if you want to use sprite 1, you need to place a memory reference in hex 7F8. The value you place there is a reference to a memory location where the sprite is stored. Previously I had these values hard-coded. For example, I had a LDA, hex 80, STA 7F8. Hex 80 is when you multiply it by 64, it's 128 decimal, and when you multiply it by 64, it's the memory location for 2000, the hex 2000 memory segment. After realizing that I had everything hard-coded, I found that we can use the power of CBM Program Studio to fix these hard-coded values. In CBM, I created a variable spr_root, sprite root, and then I set it equal to hex 3000 divided by 64, and 3000 being the location of the sprite data. Then, from that point forward, I can simply reference this variable, LDA number spr_root, load the first sprite, STA hex 7F8. Or for example, LDA number sign spr_root plus 2, load the third sprite, and then STA in hex location 7F8. I thought this was a great program improvement and I wanted to share. Now back to redefining the character set. CBM Program Studio makes this quite easy. Okay, in this segment I am going to demonstrate how to redefine the character set using the CBM Program Studio. And you see down here on the bottom left in CBM, I don't have any character sets defined. So to start with, what you do is you come up to Tools and then select Character Editor. This is a neat little character editor. It lets you redefine any of the characters you see here on the screen. I'm going to modify two characters here to start with. The first one is the period or the dot. And I wanted to shift up this dot to center it. And there's a couple of ways you can do that. The first is to use the shift function, shift up, shift down, which is a cool little function. Or you can use your left mouse button to draw characters and your right mouse button to erase characters. And so now that I have it centered, I'm going to modify my wall character, which is the reverse space. So let me find the space. This is the space, and this is the reverse space. So it's character 160. And I'm going to clear this one and draw a box around it. And let's see what it looks like if I put an X through it. Oops, kind of messed that up. Let's kind of make a little X. And let's see what that looks like as a wall character. Probably won't look that great, to be honest, but let's see. So you come up here under the character set menu and then click Save. Give it a name, and then CBM adds it to your project under here under the character sets folder, characterset.cst. And then for the program, I'm going to need it exported as a file, as a binary file. So you go character set, export to file. You have the other options to listing, to memory, or to preview, but I'm going to use to file. And you have the option here to export just a few characters, but I'm going to export all of them, and then hit OK and give it a name. charset.bin, overwrite. And then for demo purposes, I'm going to show how to load the character set here in a short little program. So let's see. We're going to load the character set in hexadecimal 2000. We're going to include the binary charset.bin, and then we're going to load the program data at hexadecimal 1000. Load the value hex 18, which is the hexadecimal value we need to put in for memory address 2000. Store it at D018. And where I got these bits, or the information here, was from a neat little website. Codebase64.org has a lot of information, and this particular page shows the character and the screen and the bitmap and the sprite addresses. So if you want to move around where the screen data goes, where the character memory is loaded on the Commodore 64, or where the sprite information is, this is the page to look at. And then I need an RTS in the program, and we can go ahead and test this out. Press F5 on CBM. And since I don't have an auto load or auto executing, I need to run an assist command to run it. But I'm going to put a few characters up here, some periods in a few places, just so you'll see it shift when I run the program. And we're going to sys 4096, which is hexadecimal 1000. And you see it shift the characters up. And then you see my reverse space. You can see it as my cursor flashes. But if I wanted to, I could poke it in a few locations. You can see what that looks like. Another capability that you have using CBM is in your screen designer. We can come up here and load the character set. So under the File menu, Load Character Set. And so we can load the one that we just created, this char set, and hit Open. And voila, without even executing the program, you can see immediately what the change would be, what it will look like once you run it. And that's a really nice feature right there. So this was a quick little demo to show you how you can modify your character set, which will enable you to make your program look exactly the way you would like it to look. And you can do that using the power of the CBM Program Studio. Okay, following up to my previous segment on the character set, I thought it'd be interesting to go into a little more detail on some of the maps and some of the decisions that I'm making with the creation of the characters, the character sets. We'll go into the screen definition layout, and what I wanted to start with, well, I have this basic screen definition, but I want to redefine the 160 character, or change it to something that's a little less boring. And also I'm going to show you the next map, map 2, which I've redefined. Isn't that cool looking? Well, these are all the special characters that I've used that I've redefined in the character set, which I have not loaded. And so you can see all the different types of characters that were used. And this I'll show you, I'll show it to you, but it is a spoiler a little bit. Not a big deal, but so if you don't want to see that, look away. So here I'm gonna load the character set, and on this screen all I have redefined is the dot or the period, and then here is my redefined map. And so I went with the straight edge. I wanted to have the hollow border look, and I like the way this looks. It's a lot better to me, in my opinion, than the other way. I decided to go with the solid border all around, and I put some lines in the middle. They didn't have to be there, just to make it look a little like it wasn't just blank space in there. I wish there was a way to, in some of these, well, never mind. Anyway, the graphics capabilities on the Commodore are a little bit limited, but I'm happy with the way this looks. I guess what I was going to say is it would be neat, I guess, if this had a solid fill-in with a different color than the border, but that's ridiculous. So anyway, what I wanted to show, I'm going to go back here to map 1. And I have some characters redefined here, and you can see these are the characters that I used on this map too. But I want to show, so I demonstrated one of the weird characters for the border to replace the wall character, and I'm going to do that with a few characters here. I thought it would be interesting to look at just the square box look. And we go up here to screen and click replace, and then just put in the character you want to replace. And you see that doesn't look bad. I don't like it very much, but it doesn't look bad. So I'm going to change the background color to a dark background so you can see it a little better. There's some overlapping, and so it's horrid. And then also you see on the right side, to me it's a little bit of a bug in the CBM Program Studio. It's not showing the last bit on the right side. I'll have to send Arthur an email, let him know, or he's probably already fixed it. I'm in the current version of the CBM. Let me get out of help. So I'm gonna click reverse here, skip down to the bottom, and I defined these are some interesting characters. I redefined this angle character, and let's swap that one out to see what that'll look like. It's pretty. This one here is probably the ugliest one I've ever done. So check this out. Screen replace. Isn't that cool? That would be hard to play. That would be really hard. Thought it was weird though. I kind of like this. Kind of reminds me of that Tim print pattern on that book that's out right now. But anyway, that was horrible. And then I said, okay, how about this one? And let's take a look at some of the combinations that we get. Let's see, 238. That's a little bit better, but not much. I've never used that. This very next one is very interesting. These are reverse characters, but this creates a reverse angle, bracket here. This is probably one of my favorites. I will consider using it, and I'll show you that. I like the way that looks, the line look. But as much as I like this one, I think there's one other one that I actually like better. And this is the built-in. I didn't redefine this one. Oh, I did redefine it. Excuse me. There is a built-in though for this. For the one that I like, for the one that I actually picked is not one that I redefined. The one that I actually think I'm going to use, I'll show it to you in a minute. This one here, let's look at these. This is one of the ones I like right here. This is, we're getting close. I like this one. I like the vertical lines. I like the contrast between that and some of them don't have the line going through. Let's keep going. And the next one is almost the same as that one, just offset a little. Let's just keep going here. This is that looks like a wedge character. Oops. That's horrible. But there is a variation of this reverse characters that I do like. I'm going to show you this give you an idea right here. 188. What was it? 233. This kind of gives you an idea, like what the wall would look like if you put something inside of it by using the reverse character. Like a plus sign, how it would look, or question mark, any of these. This is the one I showed in the previous segment right here. This is a square box. Let's take a look at that one. There's a variation on the box character that I showed at the first part of the segment. Let's look at the plus. So that's a plus. This kind of looks horrible. But anyway, going back to the bottom here where I left off. I demonstrated a few of these. I want to show the flag, the checker flag look. 171. It looks okay to me, but I would never use that. And that kind of looks like the other one that I liked, but a little blockier. And then let's look at the other checker flag. Something I like, I do like this look. I like it, but I don't like it for this game. I've seen this used in other programs, but it's not for me. And I'm getting close. I'm only going to show a couple more here. Oops. 230. Some of the variation of the vertical character. And yeah, these here are my favorite. So this, I'm gonna show my favorite one. What is that? 229. So I think I like this one the best. And I'm gonna go with this. Right now, that's my thinking, at least on this particular map. I like the horizontal lines right here on the left and the right side. It really reminds me, it's a throwback a little bit to the Atari 2600 games where it has the lines on the left and right sides. And I like that it's not all uniformly, vertical and horizontal lines everywhere. I like the breakup of the pattern a little bit. So that's this map. That's what I'm thinking about going with. I wish there was a way where I could just up and down arrow through all the characters and see what they all look like. Because I really, literally, I would do that. I would just go through all of them and see what they look like. But I kind of like this one the best. It's my favorite right now. And this is my redesign again, spoiler. My redesign of one of the maps using a lot of different redefined characters. This took me a few hours to draw up all these lines to make them look like to make it look like this. It took a little bit of time. So, and then the rest of my maps, which I'm not going to show them all, they're just the character 160, just this reverse space. So anyhow, that's a deep dive into the character sets and some of the redesigns that I've been considering for use on my Pac-Clone game. Okay, in this segment I wanted to cover yet another way of redefining the character set on the Commodore 64, and that is to copy the character set from ROM into RAM. And that there was a fairly interesting article here that I came across from dustlayer.com, and it describes in detail just how to do that. And I extracted the code from this article here. It's a great page to read on this method. And I extracted this code right here and placed it in a sample program that I wrote when I was playing around with this concept. And so not only does it copy the character set from ROM into RAM, I wrote a quick little program during the interrupt call on the Commodore 64 to shift the character's position. And I'll show you what I'm talking about here when I run the program. So you can see the @ character up there, it's shifting as the program runs. And this is a neat little way of animating objects during, a good use for the program interrupt on the Commodore 64. The other thing I wanted to mention in this segment is that I waited a week before emailing Arthur Jordanson regarding the issue that I found on the Screen Designer, and I emailed him yesterday and he got back to me with the program fix that fast. And so I really do appreciate him doing that, taking care of that for me so quickly. I don't want to pull that up. So just to show you, I am in a beta version, 3.81 beta 23, and in this version, under options, tools options, he added a size adjustment. So the number you put here is the number of pixels that will get added to the edge on the border within the Screen Designer. And so this repairs the issue on the right side. You can see there's a little gap in here. Prior to that fix, it was truncating by 1 byte. And that was in my earlier segment. So thanks Arthur for jumping on that so quickly. It is appreciated. It wasn't a huge deal, but it's nice to know that you let the developer know that there's an issue. When you have someone that's that responsive, it's beautiful. So I appreciate it, and thank you for that. Just for a brief moment, I thought, wouldn't it be neat if CBM Program Studio allowed you to test out every possible combination for an 8-bit character redefine? It got me thinking, just how many ways can you redefine an 8x8 character? It can't be that many ways, right? Maybe 1,000 or a couple thousand, I don't know. This led me on a journey all the way to Wolfram Alpha, which is a mathematics website where you can type in a specific search term if you want to know the definition. And the term for this is a binary matrix. So I'm sorry, this part gets a little bit mathy. Looking at the definition of a binary matrix, 0, 1 matrix is an integer matrix in which each element is either a 0 or a 1. It is also called a logical matrix, binary matrix, relation matrix, or a Boolean matrix. The number of m times n binary matrices is 2 to the power m times n. So the number of square n by n binary matrices is 2 to the power n squared. So for an 8x8 grid, that's 2 to the power of 8 times 8, or 2 to the power 64. So then I went over to my calculator and I plugged in 2 to the power 64, and it's just a ridiculously large number I never would have imagined. This kind of blew me away. I thought it was extremely interesting. it's over 18 quintillion different combinations for the grid. Needless to say, I gave up on that idea, but I thought it was interesting to share this little math tidbit. And finally, I just wanted to point out that 8-Bit Magazine issue 2 is on Kickstarter for you to come on and back it. It's already got their funding goal, which was only $233, and as of this recording, which is August 20th, there is still 30 days to go, so you can join in on this magazine. There's a couple of different pledge options. You can pledge for just issue 1 or issue 2, or you can pledge for more than one issue. You can pledge up to 6 issue subscription and a 12 issue subscription. So there's a whole bunch of different options that you can pledge. This is a neat little magazine, and I just wanted to point out that an update that it is now on Kickstarter for you to go and give your support.